Okay, let's move on to stochastic dynamic programming. So you saw that we can do dynamic programming for deterministic problem. In the previous inventory problem, there is no uncertainty. You know for sure that for today you need 3 units, for tomorrow you need 2 units, you know everything. And you also get the feeling that, well, what's the point of using dynamic programming? Because that problem actually can be solved by linear programming and it seems to be much more easier, right? Then why do we want dynamic programming? Well, it's because the world is full of uncertainty, okay? In practice, in many cases, you have multiple periods indeed. Today, maybe you know you need to sell 3 units because it's already today. But for tomorrow, you have no idea what's going to happen. The day after tomorrow, you don't. You probably have some estimate, but you don't know for sure how many to produce, how many to sell. So if that's the case, actually when you make some inventory or production decisions for today, you need to consider those uncertainties, right? And that's something you need to think about in an uncertain problem. So in that case, your dynamic programming actually can give you some benefit. So let's see this again. Suppose I know all the demand information for the following periods, okay? In that's the case, I can make my full production decision and inventory decision starting from now because I know everything for the next 6 days. So I can plan ahead and determine everything. Then for each day, I just need to do execution. But the thing is that there are something that is uncertain for the future. So what should you do? Actually, what you should do is that, okay, I consider those uncertainties. Today, I still make some decision. But after 1 day left, I'm going to see, oh, I thought it would be 3, but actually it's 4. I get some more information about what do we have. Then we should update our decision. Every time when we want to make a decision, we will look at how many items we have on hand. That somehow depends on the random demand in the previous period. Then in that case, we redo our decision. 1 day passed, we redo our decision. 1 day passed, we redo our decision. As long as your demand is random, then there is no way for you to plan ahead for everything, right? You somehow need to wait until that moment so that you can make the decision for that period. That repeats again, and again. So as long as you have uncertainty, there's no way for you to plan ahead, then you need to make decisions one at a time. That's dynamic programming. So later we will revisit our inventory problem, but we will consider demand uncertainty. And we're going to see how dynamic programming may help us to deal with demand uncertainty. And if we understand this example, any kinds of uncertainties may be added into your mathematical program.